Assalamu alaikum everyone. So once again we are meeting with another video on simple harmonic motion. So as I promised in the last video, right, I'm going to do a 2011 A-level question for you guys, right? So please concentrate on each and every part, and we will read the problems, and we will try and work out with the 2011 A-level problem. Cool. So it says that a particle P of mass m is attached to one end of light elastic string of natural length L. So you have kind of a string with a natural length of L. So let's say this is the natural length of the string. Furthermore, it says that the other end of the string is attached to a fixed point O at a height 4L from the horizontal flow. So you have the horizontal flow. Let's say this is the horizontal flow. The other end O is being attached 4L meters, 4L. The length is 4L from the horizontal, flow. So in that case, this length over here should be about 3L, units, 3L units. So the next part is, it says when the particle P hangs in equilibrium, so it has been connected to a particle P, right? When the particle P is connected, right, it should, since it is an elastic string, it has to go a little bit down. So this will become your particle P, right? So it will become your particle P, and it says that when the particle P hangs in equilibrium, the extension of the string is L. So the extension is L, right? So here it is the natural length. From here you are going to have an extension, and the extension is going to be L itself. So E is going to be L. So the extension E is equal to L, right? Cool. Now, show that the modulus of elasticity is mg. So we are supposed to show that the modulus of the elasticity of the string is mg. So what are we going to do? At equilibrium, we can apply mg minus t. mg minus t is equal to 0. Why so? Because the upward forces balances downward force, so you can apply F equal to ma downwards. Since the acceleration is 0, you can say mg minus t is equal to 0. But mg then becomes equal to t, right? But you know that from Hooke's law that we have studied in the last video, the tension is equal to lambda E over L, right? Now the extension E is L here, so lambda L over L. So tension is going to be lambda, right? So if the tension is going to be lambda, T is equal to lambda, meaning mg is also lambda because mg is equal to T. So the modulus of elasticity of the string is mg equal to lambda. Lambda is equal to mg. Now the next part of the question says that the particle P is now held at O. So the particle is now slowly brought to this position, right? Meaning you have kind of you have slack of the string here, and the string is slack here. Now you have tension in this position. When it is in this position, you have the string to be slack, right? The string is slack. Slack means you don't have any tension. So from O they are not releasing. They are giving a velocity square root of GL. So they are leaving it, or they are dropping it with a velocity of, or projecting it with a velocity of square root of GL. So when that was the case, the first question says that find the velocity of the particle P when it is fallen to a distance L. So when the particle reaches at this position, what is the velocity? That is the question. Now we have to remember that up until from this point to this point, the tension is 0, right? Tension is 0 in the sense the particle is falling freely under gravity. If the particle is falling freely under the gravity, we can apply the equation of motions, right? You have equations of motions: v squared equal to u squared plus 2as, v is equal to u plus at, s equal to ut plus half at squared, and s is equal to u plus v divided by 2 into t. These kinds of equations can be applied if the particle is falling under gravity. So you can say that v squared equal to u squared plus 2a. So you can apply this because they are asking for the velocity. So you have to find the velocity v squared. V squared is equal to initial velocity is gl whole thing root. So u squared is going to be gl plus 2g. The distance falling, the displacement is going to be s. S is going to be l. So you are going to have v to be root of 3g L. So these are very simple stuff that you can come up in this problem. So moving on to the next part. Next part, it says that write down the equation of the motion for the particle P when the length of the string is 2L plus X, right? So this is the equilibrium position. So from here, now you will say that equilibrium position is to be your X equal to 0, right? Last video we have learned that always, usually we take, X equal to 0 to be our equilibrium position. So they are saying that, when the length is 2L plus X from O. So, you can take this to be your X position. So X, right? So X is equal to X, right? So now when the particle is somewhere else here, now it is going like that. So when the particle is somewhere around here, you have the weight, you have the tension, you have the weight, you have the tension. So let me draw the diagram again. So you have the mg and you have the tension, and furthermore you are going to have acceleration. So this is the expression. So the acceleration x double dot is always calculated from the equilibrium position. Now if it is going downwards, it's the positive x direction, so you are having x double dot in the downward direction. Even if it is coming back upwards, it's a positive x direction, so it's going to be x double dot downward. So that is how you measure acceleration whenever you have whenever it is when you're supposed to differentiate the lengths, the varying lengths. When it is differentiated, you have to do according to the direction. Direction of the motion doesn't matter, but the positive length or the negative length matters. So that is what you have to understand. When we differentiate the length in order to find the values. So mg minus t is equal to mx double dots, because you can apply f equal to ma downwards, at any position. Mg minus t is equal to mx double dot. But Hooke's law says that mg minus lambda e over L, right? Lambda times extension over the natural length is going to be the tension. So the extension is going to be L plus X, right? Because this is the natural length. From here you have an extension L, and from here there is an extension X. So the total extension is going to be L plus X equal to mx double dot. But you know that lambda is equal to mg, so mg minus mg over L into L plus X is equal to mx double dot. M gone, so g minus g times L over L is going to be minus g times x over L is going to be minus g x over L equal to x double dot, right? Plus g minus g gone, take this to the other side, so you are having 0 is equal to x double dot plus g over L x. So this is what they are expecting. Now the next part of the question says that x double dot squared, right? Assuming that the above equations of the form x dot squared equal to g over L, c squared minus x squared, find c. So this is the next question they are asking in this particular question. So to find c squared, what we have to do is, we have learned the last equation, that is x dot squared is equal to omega squared square root of a squared minus x squared. So a squared is what? That is the amplitude. So c here should be the amplitude, but how are we going to find that? So that is the problem, right? Now at t equal to 0, when the particle is somewhere around here, right? When the particle is somewhere around here, right? At when the position is somewhere around here, meaning at the beginning of the simple harmonic motion, what is the velocity? The beginning of the simple harmonic motion, the velocity is square root of 3gl. So x dot is 3gl at t equal to 0. If that was the case, what is the x dot squared? What is the x dot squared? X dot squared will be plus 3gl. 3gl is equal to g by L c squared minus, now what is x? Now x over here is from the equilibrium position, the x is negative L, because the downward direction is the positive direction, meaning the upward direction should be the negative direction. So you have minus L whole thing squared, but minus L whole thing squared becomes plus L squared. So it's going to be 3gl equal to g over L into c squared minus plus L squared. So minus L squared. This is how it is going to be. So now g here gone. 3L squared equal to c squared minus L squared. Take this L squared to the other side. So 4L squared is equal to c squared. 4L squared is equal to c squared. If that was the case, c is equal to 2L and the amplitude is 2L, right? So the next question says that show that the particle P comes to instantaneous rest when it reaches the flow and the time taken from O, right? And the time taken from O to reach the flow is, they have given you a kind of a value, right? So to find the, whether it is coming to rest when it comes to the bottom portion, right? When it comes to the flow, you have to apply, instead of C, you are going to substitute 2L, because the extension, when the extension is 2L, what is the velocity? For this equation, if you apply that, you are going to get that. So x dot square is equal to G over L. Instead of C, you are going to put 2L, because you have to substitute that, and you have to find what this x square actually means. So 2L is the 2L squared is C, that is obvious value, 4L squared. When x becomes 2L, you are going to have 4L squared here as well. So x dot becomes 0, obviously, right? So the next part is kind of a very beautiful problem. You have to think about circles as well here, right? Circles as well here. Since we have done with the most of the parts, we will erase all these kinds of things, and we will concentrate on how to find the time, right? Finding the time is the most important problem, and most of the students mess up with this, right? So better to slowly understand this fact, right? Now from here to here, the time taken for the object to come from O to a distance of L is of course very simple. What you have to do is V is equal to U plus AT. You can apply this, right? V, final velocity is square root of 3GL. Final velocity is square root of 3GL equal to the initial velocity is square root of GL plus the acceleration is G times T. Take this to the other side, so you are going to get root 3 minus 1, right, into root of L, right? Since you have G here, if you take it down, it becomes G. So altogether the value is going to be square root L over G to be your time, right? Now how does the circular motion is going to work? Now remember, the equilibrium position is always the center, and the amplitude is always the radius of the circle. So that is the most important part you have to understand when we draw the circle. So this is the center, the radius is this. So this is the radius, and you are going to have a kind of a nice, semicircle. So let me draw it somewhere around here. So V is equal to U plus AT, right? So root 3 minus 1 into square root of L over G is the time, right? We will say T1. Now the particle has to move from here to here. The time taken should be found. We know what is omega. Omega is square root L over G, right? So I will draw something like this, right? You know that theta divided by T is equal to omega, right? Angular displacement divided by time is omega, right? Because it's moving in constant velocity. We have compared this with the circular motion initially, from the first questions, right? If this was theta, now the radius is going to be 2L. If the radius is 2L, the height, the perpendicular height is going to be L. Why is that? Because this is L. So then sine theta is equal to half. Then theta is equal to pi by 6. Theta is equal to pi by 6. Now it's a 90-degree angle. So theta, we will say this 90 degree, alpha to be alpha. So alpha is equal to pi by 2. So total theta, total angle, so the total angle from here to here, theta plus alpha is going to be pi by 2 plus pi by 6. Pi by 2 plus pi by 6 altogether is going to give you 2 pi by 3. Now 2 pi by 3 over omega, 2 pi by 3 over omega is the time. So 2 pi by 3 over omega. Now omega, what is omega? Omega is square root G over L, right? So 2 pi over omega means square root L over G. So you need to get square root L over G. So this is the time taken for the particle to come from here to here. Is also same as coming from here to here, right? So we will say this is T2, and the total time is going to be 2 pi by 3 plus root 3 minus 1 into square root of L over G, right? Now they have taken the 1/3 out of the bracket. So if they have taken 1/3 out of the bracket, what you are going to get actually is you are going to get 1/3. They have taken 1/3 out of the bracket. So root 3 becomes 3 root 3, 3 root 3, minus 1 becomes minus 3, and plus 2 pi, root of L over G as required. Thank you very much. We will look at another past paper problem, in the next video, and then we will move on to another new section. Thank you very much.